Hey students, so this is the notes for segment proofs, and we're going to go over this page very quickly, and then we're going to do some practice problems, then we're going to jump into doing some proofs. Before we jump into proofs, I want to let you read this. There's no magical way to learn to do proofs. Doing proofs requires hard thinking, serious effort, memorization, a lot of writing, and dedication. There are no shortcuts. There are no quick and easy answers. To be successful at proof, you must know every definition, postulate, and theorem. Looking them up in a book is no substitute. Every year, millions of students across the country learn proofs. You can do it too. Now, the thing about proofs is, if you copy someone else's proof just to get the grade, you're not going to learn how to do it because you're not going to learn what goes into looking at one step to another to get the deductive reasoning to go from one step to another. You have to actually do them. You have to actually do them. It is much better if I give you a proof that you write something down rather than nothing. Okay? So when I tell you you have to do proofs, you have to do proofs. This is not anything you get to skip. This is not anything you get to try to slip by. Okay. First of all, these are the properties that we've had already. The reflexive, symmetric, and transitive, we're going to cover those again right here. So make sure you know that these are the ones that you've been having trouble with getting those mixed up. So make sure you know the difference, and we're going to go over those again. So all of these up here are the properties of equality because they have equal signs in the problems. If I throw in a congruent sign, then you're going to call it the property of congruence. Up here, remember we use POE, property of equality. Down here, we're not going to say POC. We're not going to get that confusing, but you're going to say property of congruence. Okay, property of congruence. And we'll talk a little bit more about that as we go through here. So first of all, for any the reflexive property, for any segment AB, that means segment AB is congruent to segment AB. Now, how do I know the difference between congruence, property of congruence, and property of equality? Well, this is how I want you to remember. If there's something up here, there should be something right there. If there's something extra in the problem, you write something extra in the problem. The reflexive property up here would be AB equals AB. No segment above it because the lengths are equal. Well, segments are congruent, lengths are equal. Okay, so reflexive property is like looking in the mirror, or reflection. It's a reflection. Look in the lake, you see yourself. Look in a mirror, you see yourself. This is reflexive. Okay, symmetric. If AB, segment AB, is congruent to segment CD, then CD is congruent to AB. So symmetric property is switching it around. Up here we had something like if 3 equals x, then x equals 3. And we switched around the algebra. Well, now we can also switch around the geometry. This one isn't used very much, but when it shows up, we do need to use it. Okay, then the transitive property. Nope. Don't write that down. So sorry. Okay, let's look at what I have written down. So transitive property, like a train, if you want to write train on your paper, switch, reflect, switch, train. See what I did there? All right, so it's like a train. The engine connects to the caboose, and you take out the middle car. So if AB is equal to CD, CD is equal to EF, or congruent, then the engine is equal to the caboose. Think of it this way. If a quarter equals 5 nickels, and 5 nickels equals 25 pennies, doesn't a quarter equal 25 pennies? That should make sense to you. Okay, then we have definitions. This is a new one, definition of congruence. The way we're going to abbreviate this, by the way, these we will write the whole words, and then you put property of congruence after it. Okay, just like they have right here, but you can use the abbreviation. So the definition of congruence, we can just put it like that, says if segment AB is congruent to segment CD, then the length of AB is equal to the length of CD. So if we switch from congruent to equal or equal to congruent, then we're going to write definition of congruence in our proof. Likewise, doesn't matter which way we're going. If we go from equal to congruent, then we write definition of congruence. Another definition that we've had is definition of midpoint. I'm going to abbreviate this. Okay, definition of midpoint. And you guys know that if I have a picture to go with this, if M is the midpoint of A, B, then segment AM is equal to segment MB. And in my picture, that's how I mark it. Okay. All right, then we have what we had before, the segment addition postulate. We use that as SAP in our proof. So if you don't know what it means, write out the words. Segment addition postulate says part plus part equals whole. If A, B, and C are collinear points and B is between A and C, so sometimes you'll see it written like this, if B is between A and C, then AB plus BC equals AC. It is the segment addition postulate, part plus part equals whole. All right, let's do some practice. And then I'm going to ask you some questions similar to these. Okay, so the first one, if PQ equals PQ, then segment PQ is congruent to segment PQ. So if we're going from equals to congruent, that is definition of congruence. Either way, from one to the other, doesn't matter which way we go. If you're going from equal to congruent or congruent to equal, definition of congruent. We'll talk about more why we do that later on. If K is between J and L, then JK plus KL equals JL. If you need to draw a picture of it, K is between J and L. Now, the segment addition postulate, when we have proofs, we will have a picture to go with it, so you can always verify JK plus KL equals JL, part plus part equals whole. That is segment addition postulate. All right, here we go. This is reflexive. What's on the left is equal to what's on the right. Is it reflexive property of equality or reflexive property of congruence? Reflexive property of congruence, okay, because it's got the congruence symbol here. All right, if RS equals TU, then what's happening over here? What was put in? We've got XY added to the left and XY added to the right. What is it when we add something to the left and we add something to the right? Addition, property of equality. Addition, subtraction, multiplication, division, substitution, distributive property, all of those on the front. Your properties of equality are also listed down here at the bottom. Those you should be putting POE. All right, number 5, if AB equals DE, then DE equals AB. They have switched places. The AB and DE have switched. That is symmetric. Property of equality because it's equal. Guys, if you put this answer and you leave this off, it's not that big of a deal, but we do need to try to put it. Okay, if Y is the midpoint, guys, anytime we see a vocab word, that's going to be a tip or trick that I teach you when we're doing the proofs. Anytime you see a vocab word, you're going to have definition of that vocab word in your proof. So if Y is the midpoint of XZ, then these two segments are congruent because a midpoint creates two congruent segments or equal. So this is definition of midpoint. It's a new one for us, so you got to get used to seeing that. And we, like I said, that vocab word will be a big clue. I'm going to teach you when we get to the proofs. Okay, if segment FG is congruent to segment HI. Segment HI is congruent to segment JK. Then FG is congruent to JK. We have gone from the engine to the caboose. We've taken out the middle, which is the same. And so that is the transitive property of congruence. Okay. Number 8, if AB plus CD equals EF plus CD, well, what do you notice is on the left and the right? And then the CD disappears. Well, how do we get CD to leave the problem? We subtract it from the left and we subtract it from the right. So this is the subtraction property of equality. Look at the subtraction and look at the addition. Look at number 4. Notice we started small and we ended up big. We started, where am I? 7. Number 8. We started big and then we ended up small. Pay attention to those. It's going to really help you. All right, number 9. If PQ plus RS equals TB and RS equals WX, then what they've done, lightly cross out the RS and circle the WX. They have taken out the RS and they've replaced it with the WX. That is substitution. Property of equality. Okay, number 10. If LP equals PN, and these are all collinear, P is the midpoint of LN. So again, we've got that vocab word, definition of midpoint. It's just the converse of the one we had before. Okay. Here we go again. If segment UV is congruent to segment UV, and then UV is equal to UV. So we've gone from congruent to equal. That is definition of congruence. Definition of congruence. And then lastly, if CD plus DE equals CE, so a lot of people go, oh, that's segment addition postulate. But wait, we've got to see what happened from here to here. Notice, let's see, the CD is the same. The DE has moved over here, and now it is minus DE. So how did they get the DE to move from over here to over here? They subtracted it. So this is subtraction property of equality. Because if I show you this, they subtracted DE from the left, and they are subtracting DE from the right. Okay, this is great for you to have out. Property of congruence, our definitions, our postulate, and our properties of equality. Have this out while you're doing your proofs. Okay, I'm going to ask you a few questions and see if you can answer them. You might want to pause the video, and then 3 seconds later, I'll ask the question. So you're going to tell me what property this is. Okay, this is the subtraction property. So notice the LM is on the left and right, and then it is gone. The way we get this to disappear is we subtract LM from the left, we subtract LM from the right. Okay, your next question. All right, look at it. I'll give you 3 seconds, and then I'll ask you the question. Okay, if you said definition of congruence, you were right. Very good. Next question. Okay, take a good look at it. Pause the video right now. I'm going to wait 3 seconds, and then I'm going to ask you the question. If you said substitution, you were correct. What happened was we took out the RS and we replaced it with XY. That is substitution. Very good. Okay, next page of your notes. All right, this right here just says use the segment addition postulate to write 3 equations using the diagram. We'll just do one. So if I said PQ plus QT equals PT, That is the segment addition postulate. It doesn't matter which pieces I'm using as long as it equals the whole. By the way, I could also say PQ plus QS equals PS. I don't need the whole thing as long as part plus part equals whole. There's lots of segment addition postulates in that picture. Okay, let's go to some proofs. All right, now this is the way we write a proof. You look at what's given, you mark the picture with the given. Let's write this down. All right, so number one, mark picture with given, if it's something that we can mark the picture with. Okay, then the second piece will be new info. And that new info is what you can take from the given and come up with. Anything that you know, something that leads to something else. That's the body of the proof. Okay? And then that leads us to our proof statement. Whoops. PROVE, our proof statement. Okay, so then what we're trying to prove, you're going to make sure we end up with what we prove. This takes some getting used to, but the biggest deal that you have to know is that you have to mark your picture because markings tell us things. Okay, whatever's in the given, we will write given down here. Sometimes the given shows up in more than one step, which is fine. Okay, and then other tips and tricks that I'm going to teach you. If you see a vocab word, we're going to circle it, and that's going to help us find some other information, okay? So remember, right now, one of our only definitions that we have is the definition of a midpoint, definition of congruence, okay? All right, let's see what we've got. So this picture says X is the midpoint of WY. So in this picture, X is the midpoint of WY. What I would mark off of that is that this piece is equal to this piece, because that's what a midpoint does. It creates two congruent segments. And then I know segment WX is congruent to XZ. So now I'm going to put double markings here. And I want to prove that XY is also congruent to XZ. So I want to show you that we're going to see transitive show up in here. If A is equal to B, let's see, we're going to, if A is equal to B and A is equal to C, then that means B has to be equal to C. And I'm just kind of generalizing with a variable. Okay, so that's kind of where we're going to be going with this. So let's show you how to do this. All right, anything that's in the given up here, we're going to write given down here. This was given to us. And sometimes all the given is not at the front. Here's the other given piece. Okay, now we're going to go step by step. X is the midpoint of WY. What does a midpoint create? What did I mark in my picture? Two congruent segments. Okay, X is the midpoint. A midpoint makes WX congruent to XY. Well, look at what's next. So this piece came off of this statement. I want you to circle that vocab word. Anytime you see a vocab word, and it may not be directly next, but most of the time it is, you're going to see me draw this arrow. This step, if it fits, it feeds off of that word, and it's going to be definition of midpoint. Okay, because these two segments are equal because we had a midpoint. All right. All right, and by the way, these are called our statements. These are the reasons. This is what we know. This is why we know it. Okay, now this other piece was given to us. We have that marked in the picture. Okay, so look at from step 3 to step 4. Why are we doing this? Okay, why are we going from congruent to equal? Because we say things are equal in the transitive. We could yeah, so we like to use the transitive property when things are equal, and so that's basically why we're doing this. We're just going to use, we could say substitution, we could say transitive when we get here. But the reason we are going to go from congruent to equal to congruent is basically just to get practice with definition of congruence. Okay, so from here to here, it's exactly the same. It changed from congruent to equal. So that's going to be definition of congruence. Definition of congruence. Write out congruence if you don't know, if you won't remember that. And then from here to here. Now, when things start changing, we have to look, because I'm going to tell you transitive happens in 3 steps, usually. I have to say, sometimes I tell you it happens this way, and then we'll come to a proof where it's completely different. Anything goes. So I'm going to circle where the transitive is happening. Okay, so we've got Wx is equal to xy. Wx is equal to xz. So these 2 steps here, I want you to circle them, are joining together to give us this step here. And it's the transitive property, but it's also substitution. Remember I told you could use either substitution or transitive. Maybe I told you, maybe I didn't. Transitive property can be switched out with substitution often. It just depends on how you see it. So what happens here is the Wx is the same, and these 2 pieces are being put equal to each other in this step here. So whenever you can take out the same thing from 2 different steps, and then you're putting these 2 pieces together, that's the transitive property or substitution. So I'm going to write it like this. Look how abbreviated. If you're going to write out just one answer, just put transitive property of equality or substitution property of equality. Both of these are property of equality. But you do not ever have to give me double answers. You only pick one of them to write down. Okay? And then to go from the equal to congruent, it's back to definition of congruence. I promise you these are going to get easier the more we do. Okay, let's look at number 5. Now, anytime you see just a flat segment, I can almost guarantee that segment addition postulate is going to show up. Okay? So let's see what's happening. AB is congruent to CD. AB is congruent to CD. I want to show that AC is congruent to BD. Now, if I just look at this picture, I'm going from something small equal to something small to something big equal to something big. What was added to this piece and added to this piece that wasn't in the original? Well, BC was added to this little segment, and BC was added to this little segment. So you can kind of see that we're going to have segment addition postulate, we're going to have addition, we're going to have reflexive, and I'm going to show you how that all shows up. Okay, so first of all, let's put our given. What would this be? Definition of congruence. All right. Anytime you jump from simple steps to addition and you need to recognize what the segment addition postulate is, once you go to look at the picture, okay? So you're going to go take your eyeballs and look at the picture and see if it's segment addition postulate. Anytime you have addition, look at the picture. AC plus CD equals AD. That is just segment addition postulate. Well, I've got more addition, and let's see if anything changed. Not just one thing didn't change. So what happens is when you see another statement, go to the picture and look and see if it's segment addition postulate again. AB plus BD equals AD. That is also AB plus BD equals AD. That is also segment addition postulate. Notice you can use the same answers more than once. Sometimes these are written in one step. Anytime you use the same answer twice, you can write it in one step. Okay, now we got to see what's happening here. CD plus BD equals AD. Let's look at that. CD plus BD. That is not the segment addition postulate. So we need to see what's going on. Well, let's look at these and see if any of these are the same. Like, this is the same. This is the same. CD has replaced AB. Is there anything above this step that allows that to happen? I want you to look right here. Because AB is equal to CD, we were able to take out the AB and replace it with the CD. What is it when we take something out and we replace it? Substitution. Property of equality. Now, it can't be transitive. Transitive is like the train. You will never have transitive when you have addition and subtraction in your problem. Okay, it is strictly substitution. This next step, I'm teaching you, so watch. Okay, I want you to look that we have addition on the left and addition on the right. And what this is going to do is it is going to combine step 3 and step 5. Okay, step 3 and step 5. So what has happened in step 3 is I have all of this equal to AD. I have in step 5 all of this also equal to AD. So if I take this piece here and replace it here, it is putting AC plus CD equal to CD plus BD. It is taking out the AD and putting this in its place, but it's an expression. So that's why I put the box around it. So this box is going up there in place of the AD. That is substitution again. Okay. Now, that can also be transitive, depending on how you think of it. If A equals B and B equals, let's do XY. If X equals Y and Y equals Z, then X equals Z. Substitution or transitive. So either answer's right. My little rule is if you have no idea what the answer is, put substitution, you have a good chance of getting it right. How about that? Okay, now from step 6 to 7, this is easy. Look at how 6 changed into 7. What happened to this? It's gone. So if we take something out of the problem from the left and right, we are subtracting. Subtraction property of equality. And then from 7 to 8, from equal to congruent, that is definition of congruence. All right, we're going to do one more. So this time we're given 2 times PQ equals PR. So 2 of this equals this. Okay, let's see what happens. So our given, this time our given, we're going to learn to write this exactly the way it's written. I need a segment addition postulate statement. So look up here. How would I write this segment addition postulate? I would go PQ plus QR equals PR. That's the segment addition postulate. Okay, now look what's happening here. We have changed, let's see what's happening. PQ plus QR is right here. PQ plus QR and PR equals 2 of these. So I want you to think about this as they are, let's see, here we go. They are taking out this and replacing it with this. They're taking out the PR okay, in this statement here. And because this statement equals PR, they're putting the PQ plus QR in its place. So that is substitution. Substitution is probably the hardest one for you to get. Okay, now this is easy. Okay, what do they do up here to get down here? Well, the PQ disappeared on this side. One of the PQs disappeared on this side. So what did they do? Oh, they subtracted a PQ from the left and they subtracted a PQ from the right. So when you subtract from the left and right, then that is subtraction. Okay. And now remember what we're trying to prove is the last step. So let's write Q is the midpoint of PR. Well, how do I know Q is the midpoint of PR? If this piece is equal to this piece, then that has to be a midpoint. Well, look what we have right here. PQ is equal to QR, so that has to be definition of midpoint. You know what I said before about this vocab word? Where you're going to see me drawing the arrow to the next step. The only time that won't happen is if the vocab word is at the end, it's going to go. So you see that vocab word, it's going to be definition of that vocab word. And because there's nowhere else for me to put it, I have to put it at the end. Okay? All right, we're going to do these two in class just as a review. So we are done with the notes, and we'll do these in class. And then the next time I see you, we're going to do an activity before we jump into the worksheet. Okay? And so that's it with your notes. Thank you, students. Keep working hard, keep practicing, and you might want to go back and look over your definitions just to get some of these definitions that we're going to start using in your brain. Thank you. Have a good day.